Hello friends, you are watching channel number Coolage. Through this channel, we take sincere efforts to make you understand and like mathematics, science and engineering in a simple and easy manner. This video is about estimation. In this video, we will understand how to estimate non-standard values of functions with the help of derivatives. We know the following standard values. Under root 25 equals pi. Cube root of 64 is 4. Log of 1000 to the base 10 is 3. Sin 30 degrees is 0.5. Cos 45 degrees is 0.7071. But can we estimate following non-standard values that are close to the standard values? Under root 25.3 is close to 5, which will be 5.0299. Cube root of 63.4 will be close to 4, but it will be 3.9874. Log of 999 to the base 10 will be close to 3, but it will be 2.995. Sin 31 degrees will be close to 0.5, but it will be 0.5150. Cos 44 will be close to 0.7071, but it will be 0.7193. We will discuss how to estimate these non-standard values with the help of derivatives. Consider a point P a, fa to lie on the graph of the function fx. So this is the graph of the function, and point P a, fa lies on the graph. Draw a tangent to the graph at x equals a. So this is the tangent to the graph at x equals a. Take a point Q a plus h comma f of a plus h very close to P such that now Q a plus h f of a plus h very close to P. It is so close that Q can be approximately considered to lie on the tangent at P and not on the graph of fx. So Q can be considered to lie on the tangent at P and not on the graph of fx. We know that slope of the tangent at x equals a is f dash a. So slope of this tangent is f dash a. So f dash a is slope of the tangent pq. So f dash a will be f of a plus h minus fa, difference between y coordinates, divided by a plus h minus a, difference between x coordinates. This will be f dash a equals f of a plus h minus fa. A minus a will be 0, so it will be divided by h only. So we write f of a plus h minus fa equals h times f dash a. That is, f of a plus h equals fa plus h f dash a. This is known as the estimation formula or the approximation formula. We have the estimation formula f of a plus h equals fa plus h f dash a. So let us verify this formula. For a function fx equals root x, f dash x is 1 divided by 2 root x. In root 25, a is 25 and fa will be root 25, which will be 5. And since this is a known value, let us call it as the standard value. Now f dash a will be f dash 25, which will be 1 divided by 2 under root 25, replacing x by 25. It will be 1 divided by 10, that is 0.1. And in root 25.3, a is 25 and h is 0.3. So f of a plus h becomes root 25.3, which is by calculator is 5.0299. This is the non-standard value because we cannot find it directly. F of a plus h equals f of a plus h f dash a. This is our estimation formula. We will substitute the values for RHS, or we will write RHS equals fa plus h f dash a. We will substitute the values 5, which is fa, plus 0.3, which is h, multiplied by f dash a, which is 0.1. So it is 5 plus 0.03, which is the product of 0.3 multiplied by 0.1. So this gives us RHS as 5.03, which is approximately equal to 5.0299, which we have calculated by a calculator, and this is our non-standard value. So RHS becomes LHS, and hence the formula is verified. Estimate the square root of 4.1 by derivative method. Let fx equals under root x, so that derivative of fx will be f dash x equals 1 divided by 2 root x. We write 4.1 as 4 plus 0.1 equals a plus h, so that a is 4 and h is 0.1. So f4 becomes under root 4, which will be 2. We replace x by 4. F dash 4 equals 1 divided by 2 root 4. We replace x by 4, which will be 1 divided by 4, which is 0.25. We have estimation formula f of a plus h equals fa plus h f dash a, that is f of 4 plus 0.1 equals f of 4 plus 0.1 f dash a f dash 4. It will be f of 4.1 equals 2, which is f4, plus 0.1, which is h, multiplied by f dash 4, which is 0.25. So under root 4.1 will be 2 plus 0.1 multiplied by 0.25 will be 0.025. So under root 4.1 will be 2.025, and actual value by calculator will be under root 4.1 equals 2.0248, which is approximately equal to 2.025. Our approximation is very close to the actual value. Estimate cube root of 25 by the derivative method. Let fx equals cube root of x, which will be x to the power 1/3. f dash x will be 1/3 x to the power 1/3 minus 1, which will be 1/3 x to the power minus 2 by 3. That will be 1 divided by 3 x to the power 1/3 whole square. A perfect cube near to cube root of 25u is cube root of 27, which is 27 to the power 1/3, which will be 3. So we have a equals 27 and h equals minus 2, because 25u minus 27 will be minus 2. So we have fa equals f of 27, that will be 27 to the power 1/3, which will be 3. F dash a will be f dash of 27, that will be 1 divided by 3 times 27 to the power 1/3 whole square. We replace here x by 27, which will be 1 divided by 3 squared. So we get f dash 27 equals 1 divided by 27. Now we have the estimation formula f of a plus h equals fa plus h f dash a. That will be f of 27 minus 2 equals f of 27 plus minus 2 multiplied by f dash 27. It will be f of 25 equals 3 plus minus 2 multiplied by 1 divided by 27. So 25 to the power 1/3 will be 3 minus 2 divided by 27, which will be 3 minus 0.07407, which is the value of 2 divided by 27. So 25 to the power 1/3 will be 2.9259. By calculator, we get the same value as 2.9240, which is approximately equal to 2.9259. Find the approximate value of log 4.04 to the base e, given that log 4 to the base 10 is 0.6021 and log e to the base 10 is 0.4343. Let us assume fx equals log x to the base e, because we have to find the value of this. So f dash x will be 1 divided by x. For 4.04, this value, we have a equals 4 and h equals 0.04. Now fa will be f of 4 replacing a for 4. Log 4 to the base e will be, we can apply change of base rule of logarithm, in which we write log 4 to the base e as log 4 to the base 10 divided by log e to the base 10. We will substitute the values. For log 4 to the base 10, we put 0.6021, and for log e to the base 10, we put 0.4343. So this gives us f of 4 equals 1.3864. Now f dash a will be f dash 4 replacing 4 for a. It will be 1 divided by 4 replacing x by 4. It will be 0.25. Now we have the estimation rule f of a plus h equals fa plus h f dash a. So that will be f of 4 plus 0.04, that equals f of 4 plus 0.04 times f dash 4. It will be f of 4.04, which will be f of 4 plus 0.04 multiplied by f dash 4. So log 4.04 to the base e will be 1.3864, replacing the value for f4, plus 0.04 multiplied by 0.25, because f dash 4 is 0.25. 0.04 multiplied by 0.25 is 0.01. So log 4.04 to the base e equals 1.3964. Actual value by calculator is 1.3962. Find the approximate value of sine 31 degrees. Given 1 degrees equals 0.0175 radians and cos 30 degrees equals 0.8660. Since we have to find out sine 31 degrees, we will start by assuming fx equals sin x. F dash x will be cos x. We will write 31 degrees as 30 degrees plus 1 degree, so that we can write a equals 30 degrees, which will be pi by 6 radians, and h as 1 degrees, which is given to be 0.0175 radians. We have fa equals f of pi by 6, which is sin pi by 6, sin 30 degrees, which will be 0.5. F dash a will be f dash pi by 6, which will be cos pi by 6, which is cos 30 degrees, and cos 30 degrees is given to be 0.8660. So we will have f dash pi by 6 equals 0.8660. Now we will apply the estimation formula f of a plus h equals fa plus h f dash a. We write f of 30 plus 1 that becomes f of 31 equals 0.5 plus 1 degrees multiplied by f dash pi by 6, which is 0.8660. F of 31 will be sine 31 degrees. 0.0175 multiplied by 0.8660 will be 0.0151. So we get sine 31 degrees as 0.5151. On calculator, we will get sine 31 degrees as 0.5150, which is quite close to 0.5151. Find log of 1016 to the base 10, given that log e to the base 10 equals 0.4343. We have to find the value of log of 1016 to the base 10, so we will assume our function fx as log x to the base 10. Since here base of the log is 10, we cannot find its derivative. We have to change this base 10 to base e. For that, we will use the change of base rule in logarithm and write log x to the base 10 as log x to the base e divided by log 10 to the base e. Now we have not been given the value of log 10 to the base e. So here also we have to change the base of logarithm from e to 10. So we will write log 10 to the base e as log 10 to the base 10 divided by log e to the base 10. We will write log e to the base 10 in the numerator. We know log e to the base 10 is 0.4343 and log 10 to the base 10 is 1. So we get fx equals 0.4343 times log x to the base e. Now since here the base of the logarithm is e, we can find its derivative. So we write f dash x equals 0.4343 multiplied by 1 divided by x. We write 1016 as 1000 plus 16 so that a becomes 1000 and h becomes 16. We write fa equals log a to the base 10. So f of 1000 will become log 1000 to the base 10. We write 1000 as 10 cube so that this log becomes 3 times log 10 to the base 10. But log 10 to the base 10 is 1, so we get f of 1000 equals 3. Now f dash a will be 0.4343 times 1 divided by a from this. So f dash 1000 will be 0.4343 times 1 divided by 1000. So f dash 1000 will be 0.0004343. Now we will use the estimation formula as f of a plus h equals f of a plus h times f dash a. We will substitute the values. We write f of 1000 plus 16 and it becomes f of 1016 equals 3 plus 16 times 0.0004343. 16 times 0.0004343 becomes 0.0069488. So we get log 1016 to the base 10 as 3.0069488. On calculator, we get the same value as 3.0068937, which is very close to the value that we have found out, 3.0069488. So this is the approximate value of log of 1016 to the base 10. Find the approximate value of tan inverse of 0.999. We will assume fx equals tan inverse of x. Its derivative f dash x will be 1 divided by 1 plus x squared. We will split 0.999 as 1 minus 0.001 and write a equals 1 and h equals minus 0.001. Now we have fa equals f1, which will be tan inverse of 1, which is pi by 4. F dash a will be f dash 1, which will be 1 divided by 1 plus 1 squared, which is half. So f dash a equals f dash 1 equals 0.5. Now we apply the estimation formula f of a plus h equals fa plus h f dash a. We will substitute the values. We get f of 0.999 equals f of 1 is pi by 4, and the product of minus 0.001 multiplied by 0.5 is minus 0.00050. We write tan inverse of 0.999 equals pi by 4 is 0.78539 minus 0.00050. So we get tan inverse of 0.999 as 0.78489. Now on calculator, the value of tan inverse of 0.999 is 0.78489, which is equal to 0.78489. So we get the same value as we get on the calculator. Find the approximate value of e to the power 2.1 given that e squared equals 7.389. Now e squared equals 7.389 is the standard value given, and the value of e to the power 2.1 will be close to 7.389. Since we have to find the value of e to the power 2.1, we will assume fx to be e to the power x. Its derivative f dash x will be e to the power x. Now we will split 2.1 as 2 plus 0.1 and write a equals 2 and h equals 0.1. Fa will be f of 2, which will be e squared, which is given to be 7.389. F dash a will be f dash 2, which will be e squared, which will be 7.389, given value. Now we will apply the estimation formula f of a plus h equals f of a plus h f dash a. We will substitute the values. We write f of 2.1 equals f of 2 is 7.389 plus 0.1 because h is 0.1 multiplied by f dash 2, which is 7.389. Now the product of 0.1 multiplied by 7.389 will be 0.7389. So we get e to the power 2.1 as 8.1279. So this is about how to find approximate values of functions. If you like this video, please subscribe this channel. Share this video to your friends and relatives. Thanks for watching. Have a nice day.